Recording in progress.
Is the other mic in this room decent?
Your volume turned on.
Yeah, just left. Let's see if I can.
So we're on the room. Can you hear us, Julie?
Yeah, we hear you.
Okay, great. So I don't need my own turned on. Okay, so yeah, while we're just waiting for people to join, I just want to do a quick plug for the
I think that you unmuted, muted yourselves.
Yeah, thank you. Okay, so as you might know, as well as the GWS catalog, EBI hosts a whole number of other major data resources, such as Ensemble, Europe PMC, Uniprop, and many others. And currently we're doing a value and impact survey. So if resources hosted by EBI have saved you 15 minutes or 2 hours or a year of your work over the course of your career, we'd really appreciate it if you filled in that survey, and so we can demonstrate the impact of data resources on the community. And I'm just going to post the link in the chat there. So yeah, please fill in the survey, pass it on to your colleagues. We'd really appreciate it. Thank you. So we've got 15 people on the call now. We can probably make a start.
Okay, great. Everyone hear me okay? Okay, I know you can see my slides in the non-presenter view, but that's deliberate because I'm going to be switching tabs. So just bear with the not so nice view. So yeah, I'm just going to be, this is our third working group meeting. I'm just going to be giving a quick update on where we stand with the benchmarking activity. So we've created a strawman standard and we sent it out a little while back. So I'm just going to update on that before moving on to the general topic of metadata. So I'll be doing a general intro on that. Then we have Marcus, who's a guest speaker. And then we have Yue talking about our attempts at creating a metadata schema. Okay, so this is our general overview of how we think of a predicted effective gene list or matrix. So we have a set of metadata that describes the data set. So like I said, we're on the third version of our strawman now, which we iterated over, and we sent out the activity we want to do is to get people to see if they can fit their various gene matrices and effective gene lists to our strawman standard to see if it's any good and to see if it can be improved in different ways. So this is the timeline that we're working towards. Like I said, we sent out the strawman version 3 standard and template with some instructions to volunteers who we had to engage in this benchmarking activity a couple of weeks back. The ask was just to take a quick look at the overall structure, how the template looks, if the instructions make sense, and if there's any significant glaring issues with respect to fitting your data to that strawman. And it would be great if we have any feedback on that at this time to hear that. But we know that a couple of our volunteers, the benchmarking volunteers, aren't on the call today. They're not available. So I'm just going to go through the template just to show everybody what it looks like. And it would be great if anyone has feedback on that. If you want to, so Julie shared the link to that template yesterday in the email, but you can also find it on these slides. We're trying to keep these this slide deck updated with links to the various data sets. So my Zoom bar is blocking things that I want to see. Okay. So yeah, I'm just going to whiz through this just to show you what it looks like in case you do want to volunteer. It's got some instructions here showing what to do. So you basically assign yourself to some data sets that we've selected on this tab, on the assignments tab. have a look at the data, or you can use your own data if you wish. Have a look at the data structure, and assess it with respect to the strawman version 3 tabs in this file. And then we would ask you to choose one exemplar trait just to reformat into the strawman template, reformat the data. This involves categorizing the evidence into evidence categories that we discussed in these working group meetings previously, and they are included in another of the tabs. You can try and create a metadata file. We have included like a really basic metadata structure table, but we're really going to discuss that today. So the metadata ask is just to try and define the column headers and capture the provenance and details of the data content. Yeah, we would encourage you to look at the original data, keep notes on what you're doing, and return some files into this Google folder that we've provided. So this file also includes like an overview of what the structure looks like, description of what's in the metadata file broadly, high-level overview of the structure of the data file, which we've presented here before, the variant locus gene, the evidence, and then the integration sections. And then we have a specific a template, a data file template showing the different column headers, some of which are specified, some of which would be user specified, example data, format, whether we think they should be mandatory or not, and some descriptions. So you can see the different sections: variant, gene, locus, evidence, gene-based evidence, and the integration section. And then we include the evidence categories. As we've discussed previously, these are divided into variant-centric evidence, so evidence that relates primarily to the variant, and gene-centric evidence that relates primarily to the gene. And then, yes, the metadata table, which, like I said, is not very structured at this point, but we will discuss that further. And a notes column to get your feedback on how the process went. So that's what we've sent out. If anyone has had a chance to take a look at that and has any feedback at this point, we'd be really grateful to hear it. Otherwise, we can follow up offline. Can't really see all the participants, so if you do want to speak, just unmute and go ahead.
This is Matt. I did take a look through it, and it looks pretty straightforward and clear. So,
Oh, great.
Yeah.
Great. That's a good start. Yeah, so this link is now it's available for everybody to take a look. So if anyone wants to have a look, even if you don't want to volunteer to do the full activity, please feel free to take a look and give us any feedback. And then we'll follow up separately with the people we know to be volunteers. Anything else on that at this point?
Hello, it's Simon from Open Targets.
Hello.
We had a brief look, because we got the time yesterday, but we had the brief look on the thing. Looks reasonable, and the only thing, we have a few questions about the metadata, but I guess we can address them today.
Yeah, that makes perfect sense. Yeah. Yeah, we sent it out a little bit late, basically, because we got in a bit of a tangle about how to represent the metadata. And we realized that we didn't really know enough about it, and that's why we went to speak to Marcus, and that's why Marcus is speaking today. So that brings me onto the subject of the metadata, right, which we haven't really discussed in great detail. So I'm just going to go over some like really basic considerations about the metadata that we need to like think about when we're creating the metadata that we want to put in place for this standard. So just to remind you, metadata is a set of data that describes the data content, the data content table or the matrix data. As this picture comes from, I think, the first workshop meeting, and we've been clear from the start that we think this should identify the source of the primary GWAS data, and it should provide the sources for each of the different evidence types and describe the methods used to integrate them in the data content. As one small example, So this is a piece of data that's in that template from before, the kind of metadata that you might find for this variant information would be what kind of variant this is, the genome build, and information on how this variant is selected, if it's selected by some kind of special means. So when we're thinking about the wholeness of the metadata that we want to create here, just metadata is really crucial for the fairness of the data, the findability, accessibility, interoperability, and usability. Metadata are data about data, but the distinction between data and metadata is not ontological, right? There's no it's about how the pieces of information are used. So what is data and what is metadata? It's kind of perspective. So the metadata that we have may be useful to many people as data, just to note that. It's really important for us to consider our use cases, which are to allow comparison between the different lists that people create, so the interoperability of the data, because ultimately we want to facilitate a generation of gold standard lists so that people can compare across and find things that multiple people have found. It's really important for us to consider the reproducibility of the data sets people are generating, so that it really needs to be transparent, the provenance of the different evidence streams that people are using. We've talked a couple of times about how we want this data to be AI ready, that a big use case is that this will be ingested into AI algorithms, input to bioinformatic pipelines. So it's really important that this be machine readable. We want to think about interoperability with existing or emerging metadata standards. So one in particular that we've thought about is Croissant, which is a new emerging standard for machine learning data. This has been getting a lot of uptake. I know the Open Targets folks have just started using it for their downloads. So that's something we need to consider. And we're not going to go into it in great detail today, but it's worth keeping the idea in your head that ontologies might be really useful in the metadata to allow interoperability, extensibility, about how we represent the things that are represented in the metadata. And just to note, there's a couple of ones that we could consider. Sorry, this is quite small. The evidence and conclusion ontology describes different types of scientific evidence. EDAM is an ontology of data analysis and management. There's things like Uberon for representation of cell types, tissues, that kind of thing. And experimental factor ontology is what's called an application ontology. So it pulls together many different ontologies and it might be useful. So like I say, I'm not going to go into any more detail on that, just to plant the seed that we might want to consider ontologies in the future to include in the metadata. So really what we need to decide here is what the content, what goes into the metadata, how it's structured, so like the schema, and specifically what file format we might want to use to represent it. And I will show this again, because I've showed this before, but it's worth revisiting. This is the trade-offs triangle that I've shown before. So if we think now in terms of specifically in metadata, if you concentrate on the bottom right-hand corner of the triangle, thinking about high quality, rich metadata really increases the fairness of the data. But we always need to bear in mind that if we want that kind of data, that will put a burden either on your data generator in terms of skill, in terms of time to produce data in that format, or it will require some kind of retrofitting, and that means there's a cost on the curation side. So just, again, keep that in the back of our heads that we need to strike this balance. Okay. So like I said, yeah, we got ourselves in a bit of a tangle about how to represent the metadata, so we want to speak to Marcus, and it was very useful, so we thought it would be interesting to hear from him today, basically what he told us a couple of weeks back. Do you want to take it away, Marcus?
Is it my turn to present them?
It is.
Yeah. On it. One sec.
So
Okay.
we haven't introduced Marcus is a metadata bioinformatician who works at the EGA here at the EBI, so the European Genome Phenome Archive.
Yes.
Stop sharing.
Let me know when you see my screen.
Looks good.
Yep. Okay.
Yep.
So just like if I was saying, I was asked here to present a very high level overview of metadata, which I titled "A Story of Metadata." So it is the grounds. Let's say it's not as specific as what Aoife presented. It can be applied to the PEG, let's say, instance, but this is more generic. And I was asked for a very high level overview, and I'm emphasizing that as I speak. You will see why. But also, I'm trying to make this rather entertaining. So you'll also see why I'm saying that little disclaimer at the beginning. So as you introduced, Aoife, my name is Marcos Casado Barbero. I work at the MLEPI, and I work as a senior metadata bioinformatician at the EGA. So, oops, not the, sorry, pointer. So I have structured these talk in 5 different sections, starting with an introduction, then the path to a standard, the technicalities of a standard, a very brief example that I have from the federated EGA, and finally some conclusions. And I want to start the introduction with something that I created for a poster a couple of years ago, obviously inspired by XKCD style. And it's not about how funny this comic may be, it's about using it to make the distinction between 2 different concepts, or 2 different things, which are the concepts and the terminology. So we all use different terminology to refer to the same concepts in some cases, and that's normal. That's in our human nature. We use this terminology because it's familiar, it's context dependent. So where we worked, where we studied, where we grew up, etc. And it's not until we, like Aoife mentioned, it's not until we need to make some kind of improvements in interoperability, because we need to communicate and use these data from different sources or across different institutions, that we actually need to question what we use, the terminology that we use. And that brings us to a very famous allegory, which is the allegory of the cave by Plato. Just a small disclaimer, I'm using this allegory as an analogy that I literally came up with, I don't know, 2-3 days ago. So if it may very well be wrong, I literally just made it for this presentation, but I think it's rather useful to present what we talk about, the need of a standard. Why do we need a standard? We use different terminologies for the same concepts. I don't have enough time, unfortunately, to go through the whole allegory, but you can imagine that it has 3 different components. On the left, we have prisoners whose whole existence has been based on, let's say, a false premise that these shadows are true. Then on the second layer, you have the objects that cast these shadows, let's say the human approximations of the real world entities. And finally, on the third layer, outside of the cave, you have the real world entities, or the concepts themselves, the truth, let's say, the maximum level of abstraction. And we start our analogy on the left, defining who the prisoners are. And unfortunately, we are the prisoners, especially at the beginning of our science journey. We see the shadows differently, and we are content with that. We are happy. These shadows, and again, going back to the analogy, these shadows could be, I was always taught that human sample is the term for this entity or this concept. And then someone very understandably may say, well, actually, my master's degree, they taught me that it was patient biomaterial, or whatever other concept, sorry, whatever other terminology for that concept. And we are happy with that because it's useful, actually, within our lab, within our masters, within our group. Those terminologies actually represent the concepts that we refer to, and that's useful, that's okay. But it is only through the path to enlightenment, we will call it, that through science we start turning around and checking on the other prisoners and trying to exchange information with them. And that's when we see the constraints of the shadows, that the limitations that they entail. So that's when, let's say, we turn around and we see that what we took for granted, which was that the shadows are the truth, are fake, or let's say are just a fidget of our imagination, because the objects, which are the human approximations, are casting these shadows. So that's when we actually start challenging our own reality, and that's actually rather uncomfortable. So you imagine that not everyone wants to do that. That's why obviously there is this kind of reluctancy in adopting standards, because it's just challenging your reality, your version of reality, and how you use it. So as I was mentioning, we turn around, we see these objects, these human approximations that we will actually call standards in our analogy. These objects that cast the shadows are the best approximation that we as humans can get. And this is to say that the goal is actually not to come up with the real abstraction of a concept, because we are humans, and in our human nature, we can only approximate to these concepts. And that's through these standards, through the ontologies that Aoife also mentioned before. But imagine that we actually, or you or whoever, gets actually outside of the cave, and you manage to get into the abstract world or the real world in the analogy. You see the concepts, and congratulations, you have become extremely enlightened in a very particular subject. But when you try, as a fellow scientist, when you try to educate your coworkers or many other communities, for example, if now the PEG group that we are forming wants to educate other kind of groups, other laboratories, other institutions, maybe national health institutions, etc., you will be faced with kind of, I was going to say aggression, not aggression, but displeased emotions, because obviously no one wants to challenge their own reality. So when you go back to your prisoners, to the other prisoners, and say, by the way, your whole premise of truth is wrong, they will probably start lighting the torches and bringing up the pitchforks. So rather than that, what we can do, and what we are actually trying to do here, is to come up with a trade-off, a middle ground, which is the ontologies, the standards, some kind of human approximation of the real concepts. That is to say, all of this is to say, lower your expectations. The real concepts cannot be discussed. It's more about the human approximations, and that's what we are aiming for. So now we go on to the path to a standard. And again, I wanted to make this rather entertaining, so I'll try to make a simile that I did with you and Aoife a couple of weeks ago, which was building a standard is almost like building a story. So once upon a time, the first step is to define the genre. And just like Aoife said, and this is super important, metadata is very broad. By definition, it is data about data, but that can entail everything. You can go into levels of abstraction or levels of definition one by one. So what are we referring by metadata here? Are we referring to the user's metadata, like passwords, usernames, where do they live, etc.? Workflow metadata, like the timestamps, how much time something took, how many servers you used to run a workflow, or you're referring to something like sample phenotypes, variant loci, experimental design, evidence types, etc. So once we have defined the genre, what we have to do is, again, in the analogy, we cast the characters and outline the plot. It's very good to define a story, but we cannot just transmit the story without actually defining the elements and how they relate with each other. And we should do this in a human readable and machine readable way, as Aoife also introduced before. And what we are actually referring to here, again, within the analogy, is to a metadata model. So the metadata model is basically the first level of abstraction that you do when you're trying to communicate some kind of level of metadata, structured metadata. And here, for example, we are casting the characters. This diagram, you see some elements, different colors, don't mind too much about it. I literally came up with them the other day, just glancing through the Strawman spreadsheet that Aoife shared before. And I had no feedback, so probably it's wrong, but this is just to represent that we first cast the elements, we cast the actors. And then when we have the actors, we have to outline the plot, which basically means just define the relationships between them. And then again, this is done in rounds of reviews. So basically, for example, me right now, I present you this diagram. We put it in a whiteboard, we edit it, we change the elements, we add new ones, we subtract some new relationships, etc. And then we present the new proposal to the community. And you do this in rounds, and believe me, it takes forever sometimes, but it's actually the way to go, because that way you get some kind of global agreement on the plot. But the issue with this is that we cannot easily transmit these abstract concepts. Yes, it's a diagram, but and it's rather already in a format, which is an image. But how do I transmit this so that it's easy to read by machines, but also humans, and it's also, let's say, versioned? What we do is choose a script and style. And this in our fields is called serialization, which is basically just putting it in writing. And once we have it in writing, and there are formats for it. So you can have it in like Aoife also was mentioning before. You can have it in JSON, XML. You can actually have it in a spreadsheet like you have already, but obviously there are different levels of automation depending on the format that you choose. But once you have it in writing, you can actually start applying validation to it. You can tell people your metadata does not comply with my standard. And once you have that, the last step is just basically the adoption of your standard. So this was very high level overview of the path to a standard, but now we get a little bit more into the technicalities. Again, very high level overview, but a little bit more in detail. So the standard requires, I would say, in my opinion, 5 bare minimum things. And the first one is a human readable format specification, which is basically just the description of your standard for people to understand how you define this standard, etc. Then you have the machine readable schema, which is the true formal constraints that allow for you to automatically validate if something is compliant with your standard or not. Then you have the implementation, so anything that enables the adoption of your standard, and these some examples that I cite here, for example, validators to grab the schemas and check if something is valid, converters between different formats, the user interfaces, user toolkits, etc. It's I cannot emphasize this enough. It's not, I was going to say mandatory, but it's not mandatory. It's essential that these last two things are open source, have a proper license, are modular, are scalable, and have semantic versioning or follow proper semantic versioning. I don't think, and this is just my opinion, but I don't think anyone will trust your standard if these are not implemented properly. The fourth element is governance. So a change protocol process, which basically involves some kind of document or I don't know, an expression of the knowledge that you know of, who has access to the standard, who modifies the standard, who has the right to modify standard, how often does the standard get modified, etc. So this can be just, let's say, a piece of paper that says so, or it can be more advanced with automation. Then the last step is the community assets. So this involves things like documentation, examples, compliance tests, but one of the most important ones is the channels of feedback. So how does your community, the one that the standard is for, how does that community feedback into the standard with their inputs and their knowledge? And then, so yes, I basically gave you an overview, but let's go a little bit more into detail with an example. And the example that I'm going to show you is the example of the standard for the federated EGA. So the federated EGA, I won't get into the details of what it is, but you can imagine it if you're not familiar with it already. The federated EGA is, let's say, a network of archivals for human-derived data. So it's all across the globe as of now, and we are growing not just European, but international. And we actually, as a matter of fact, just published a paper this very same year. So there are lots of resources if you're looking for more information, but just take it as in, if there is a network of so many different countries all across the globe, we need a standard, some kind of common language to communicate with one another. And the way that we are doing right now within the federated EGA is building a metadata model. And this metadata model, as I mentioned in the previous section, we will see what are the true examples of these 5 elements that I described. So for starters, we are building, or rather we are writing and almost done with the federated metadata model technical report, which is the human specification, and it also contains the governance, besides many other details. Then we have the federated metadata schemas GitHub repository, which will be the place where this information will be hosted. So once we finish with the report, it will be put into the GitHub repository. In this same GitHub repository, we have the JSON schemas. So this is the format that we have chosen already for the metadata validation, the serialization. Then for the validation, we not only need the schemas, we need a validation tool, and that's the biovalidator, which is an Elixir output, the Elixir biovalidator. And it has many handy features, which is one of the reasons that we chose it over just common validators like HAV and such. And again, as I mentioned before, all of these 3 elements will be and are already, if not, open source. They have a proper license, they are modular, they are easy to integrate in existing workflows. They build easily with the scale, so you can deploy multiple validation servers, etc. And finally, the last element that we are missing is the community. So within the federated EGA, which is rather big, if I may say so, We have particularly a group that is the Federated EGA Metadata Working Group. We have a Slack channel. We have recurring meetings. I co-lead that group with a couple of other people from the same Federated EGA. And we have recurring meetings, etc. So there are ways in which their input can go back into the source of the standard. And just to finish, a couple of conclusions. First of all, as I mentioned, an ontology is not the end of the journey, it's the method. Our goal is to minimize distortion because we can theoretically not eliminate it, so lower your expectations. An abstract model is the stories, plot, and characters. Serialization is a printed book. So I would very much recommend that you nail the first before you actually go into the second, because otherwise feeding back retrospectively will be difficult, especially if it's already in production. This is standard. A standard is sustainable, in my opinion, only when all 5 pillars, so specification, schema, tooling, governance, and community, exist together. And finally, if you're going to do an implementation, please do it open version, follow some modular approaches so that people can actually trust it, they can extend it, and finally integrate it in their platforms. Because that's the adoption step that I mentioned before. And that's all, folks. I hope that I'm still in time. I believe so. So we will accept maybe 5 minutes of questions, if there are any. If not, we can probably move on to the next section.
Thank you, Marcus. There's a lot to think about. Does anybody have any questions, comments, thoughts? In general, or with regard to what we are trying to develop?
I'm glad that everything was super clear. If you want, we can pick random names and ask questions. I'm happy.
I think that's really useful to help us think about, especially the abstraction and the serialization part, to kind of clarify our thinking on that. That's really useful. Thank you.
I guess a difference, well, we don't really know exactly how we're going to implement this standard, but it's very possible we may, but it's also possible that we won't have a single place that people will deposit these things, right? Like the EGA, you can kind of gatekeep and say only the data that's valid we can take. You have a stick to implement your standard.
It's a stick that is evolving, if I may say so, because the stick was at the beginning when EGA was one, but now with the Federated EGA, it's not just one stick. There are multiple sticks and different formats, unless we come up with this common model. So I believe that even if there is no single place of submission that you can gatekeep and say things that pass the standard go to submission, things that don't, please, amend them. I don't think that defeats the purpose of a standard. So even then you can implement all of these steps, even if you are not an archival per se.
Do you have any thoughts on mandatory versus optional? Because I think that's something we're considering when we're thinking about striking a balance for different types of people who'd be creating this, all the way from individual labs to like high level people, that making, and I think there's something that the GWAS catalog thought about a lot with their standard, is like really thinking about which fields absolutely need to be mandatory versus which are optional.
So the way to do this, I would say, is just ask the community. I'm in no position to kind of tell you what fields are required. I would just say what is already out there. And I'm sure that you have already done this job, and probably actually you right now, when she presents, will bring up the mandatory and the optional. But I would say what is already out there and what is the bare minimum that a researcher can grab and reproduce and come up with the same results. In like reproducibility and what is already out there would probably be my 2 key topics.
Yeah.
Okay, we should probably move on to Yue's presentation. Time.
Thank you, Marcus.
Yeah, thank you very much.
Sorry, could I ask if everyone can see my screen?
Looks
Yeah.
good.
Okay, lovely. Thank you. Yeah, so thank everyone back to our to our meeting and continue our discussion. And also I want to thank Marcos for suggesting like the methodology on designing the metadata, because abstraction and serialization are really useful for us to think about how we should structure our the metadata. So actually somehow we continue with the logic at here, and the first thing that we need to cast our main actors for our the peg matrix. So from the table, it's really obviously we need our variant locus gene evidence integration as our main cast. So they may need some of support cast. And they're not like the whole story, because whenever we mention about the table with metrics, we are trying to show like the contributions of the genes to the trait. So the trait is also another really important concept here. And JVAS is another one, because we define our the metrics as a post-JVAS analyze. So the JVAS as a data source is also really important actors in our show. So as Mark mentioned, like all the main cast here, they need to have a relationship with each other. But here I only show our main cast, because if I show everyone here, this page is never be enough for all the details. So I only show the main cast here. So it's simply to say we are starting from a trait, we are interested in weights, and we're also looking for the JVAS that links the variant and the traits together. So as opposed to JVAS study, we're starting from the variant. We're trying to say if the variant in any locus, and we can find any genes in this locus. Or the other way, trying to say the variant itself has the evidence to support this variant can be more causal variant, or showing the evidence link with the genes. And the genes itself also have the evidence to say they have a stronger relationship with the trait. So gene has the over gene centric evidence. So if we combine the two levels of evidence together, that is our integration, is our the final actor here. And integration itself can also, like make the integration as other evidence to have a new integration score. So it can be self-looked at here. So that is a really simple relationship between the main cast we have right now. And for the following of that, I may go to one by one for our metadata thinking.
Does anyone need a minute to digest this? Any comments? Because we.
Well, didn't we not want to get bogged down?
Okay. Yes.
Okay,
Okay. Maybe we
let's
should
move on
continue.
to the-
Yes. Okay.
Yeah, because this diagram can be phrased in any way. So here is only to show like they have a relationship with each other. So I was starting with the trait and the JVAS, because they are two special entities, because they only show in the metadata. Our table data has no content for them, so they should be fully described in the metadata. So for the traits, the first one will be most easy, is a free text trait. You can describe the trait in any way you want, but we also strongly suggest also ontology, because ontology will help your data to be widely searched and reused. So ontology will include the ID and term for standardization, that is trait. And the JVAS is so it's really important to clarify the source of the JVAS data. So if the JVAS from the JVAS catalog, they have a JST ID, so it's really clear. All the metadata is already in the JVAS catalog already, so it's not necessary to repeat them again in the metadata for the peg matrix. However, if the data is not from the JVAS catalog, it's only from other resources, so we will highly suggest to describe the sample information. So that one gives the users the confidence to say how confident your JVAS p-value it is. That is our proposal for the trait and the JVAS. And for the rest of the entities, they are both shared by the table and the metadata together. So actually, like the Marcus also mentioned, like the data, one data. So for all the information for one actors, they should be fully described by the table data and the metadata together. It only depends on the human to define which part should go to the table data, which part should go to metadata. So at here is our proposal here to say, in the table data for the variant, we already have the chromosome position and their effect allele and reference allele already. And in the metadata, it's more important to share the type of the variant. For example, if that comes from the significant variant from the JVAS, or it's from the index variant from the critical site, so we need to know how you generate the variant at here. The genome build is important because we are using the chromosome position, so it's really important to know which genome build you are looking at. And the last one is for the information. Information is useful to say, if the variant is not come from any like the latest central index one, is any special method you are using for selecting the variant? So we need the free text informations at here to know where the variant they comes from. That is for the variant. And the locus is that in the table data, we already have the locus range already. And in the metadata, it's important to share how you define the locus, whether they are the LD block or any credible size, or it's a human-defined fixed window. We need to know how that one is defined. And for the genes that one, in the table data, we already have the gene ID and the gene symbol already. And in the metadata, it's important to know the version of them, because both of them, they are dynamically updating, keep updating. So we need to know which version it is, so we can always trace back to say, oh, if they have any change on the gene ID or gene symbol. So they are the most simple, like the entities we have right now. Could I have a short stop at here to say if you have any question, to say if anything we're missing, or do you think that was reasonable? Okay, seems like these simple entities are really clear to go on. So next, we are studying some of really complex entities here, which is evidence. So one of the difficulties for PEG matrix is because it's describing the gene and variant together. So it's really important to know when we have evidence to support its connections, whether we are talking about variant or gene. That reason we classify all our evidence as a variant-centric and gene-centric. So first of all, we need to know which one you are talking about. We need to know whether you are talking about variant or gene. So for the specific, for example, the variant-centric evidence, we also need to know the category, because as Aoife showed you, we define the categories currently, and the categories is important to know. We are talking about variant to variant or variant to gene, and also categories important to know the methodology you are using, whether you are using the QTL data or using the file mapping. These are also including methodology information. Abbreviation is a short category name, so that one can be repeated in our table data. It's easy to let you know which column we are talking about. And for the evidence stream, it's more information about the pernodless of this data. For example, like the evidence stream tab, for example, like the NQTL data, including the EQTL, PQTL, SQTL. So we need to know which specific tab we are talking about. And the source of the data is to tell you like the sharing the all the information about where the data comes from and who they are. And the software to say if the source data is being reanalyzed to present in the matrix, we need to know which software they are using. And last one to say that if the software is not applicable, so we are asking to say you need a free text description to know how this evidence is generated. That is the method part. And for each of them, we need more information for them. For example, the source informations, we need to know like each of the source, they may have their corresponding column. We need to know which column you are talking about for these resources, and the name of the source data, version of it, and the link for this source data, if it's applicable. And for the software, it's the same. We need to know the name, the threshold. If you filter on the analyze the results, we need to know the threshold, the version, URL, and if any publication available, we need to know the DOI numbers of it. And the last one is for the column description. So the column is not only the column headers, we also need a short description about the column content to know this column, their data of the p-value, their data of the probabilities. We need to know more information about this column. That is called description. So that is our schema, but how that one link with our real data? So I show example of here to say in our example Strawman version 3, we can say there is a QTL, EQTL data for the pancreas tissue. We have the p-value and the confidence interval in the same table. There are two columns for it, which means the QTL data is really obviously the variant-centric evidence, and they are under the category we define of molecular QTL. And for the data streams, so they're not the PQTL, they're not they're the EQTL data. So into specific the tab at here. And for source of them, I'm using the GTEX data from version 10, downloaded directly from the website. So I'm reanalyzing it with the FastQTL data. And also I'm not showing all the data. I'm showing the threshold with the p-value is more significant. So I have a threshold of p-value of 0.05. And also for this software, I'm not using the latest version. I'm using the older version of the 1.0. And also I give the publications and like the URL link at here. That is for the software. So the link with the metadata, with the table data, the more important part is our column part. So I have to say the header, it repeats the header name of the column. You can see it's repeated here. And the description is to say this column is a p-value, and they are showing from the pancreas tissue. That is the description for the column. That is for the evidence, which is the most complex entity in our whole metadata structure.
I think Marcus had a comment on the complexity there, which I think
Yeah.
we have touched on in the past. Do you want to expand on that, Marcus?
Yeah, my comment is that if these three elements can be compacted into a single one, then I would probably recommend for you to do so, or maybe two of them into one. So, for example, and again, as I mentioned in the comment, it's my uninformed point of view. So perhaps they are different actors, but potentially what you are doing is increasing the complexity of the model with very little value. So what I would expect, if this works, then that's even better, I believe, is just an array of different evidence streams that have potentially a field, a characteristic of them that says this is my category, and you don't need to collect them into different kind of subgroups, subboxes. It's just an array of things that have a different category.
Yeah, and I think we did consider organizing.
Yeah, true.
Mm.
Yeah, it's really lovely structure. Yes. So based on time limitations, I continue firstly, and I know some of the suggestions on the chat, and we can go back to them all together when I finish it. So the last entity is integration. So integration is quite special because they combine all the evidence we mentioned in the evidence part into one score in the integration. So in the integration part, we suggest firstly is name your integration, like a method. So because they are not always have the proper name for it, so we suggest you to name your open score here. And the second one is the mode, to know whether that one is customized, manually defined, or is some software generating the computational score. And the column is the same. We need to know which column you are talking about for this integration method. And evidence integrated, because integration, you combine so many things together, and it's really difficult for people to know how it works. So we strongly suggest listing the evidence using for this integration score here. Software again, and method the same. If the software is not available, define the method using the free text out here. Column again with a header description again, and evidence integrated, quite special to this part. It's evidence stream type, we're trying to list the evidence in the evidence blocks, but maybe not all of them in this one score. So just listing the score integrated in this method, that is enough. And as we mentioned, like the integration score can be integrate another method, so that can be nested. So if any integration analyzer you used in this score, also list them separately. And the software is the same name threshold, maybe not really useful for this one, a version URL DOL again. So in the real world, that will be looks like in this way. To say, thinking about the first example that we're representing the POPs score at here, it's only a single column your table data, which means we need more description on our metadata. So firstly, I name my analyzer as a POPs, and this one is generated by the software, so it's a computational analyze. And for the column, I'm referred to this column at here and have a short description in my metadata. And for the evidence integrated, because POP is a software, they have so many computational inside of it. So basically, for this one, I'm using, for example, the functional prediction, the QTL data for mapping interaction favors, TVAS for this integration analyze, not others. And this one is the single integration, so there is no other things nested under it, so it's empty. And for the software, the same. I'm using the POPs, the version 1.0. I also link the GitLab their source code as well as the DOI publication at here. That is for the software integration metadata will looks like. And maybe you feel confused to say what I mean for the integration with another integration. That is example to say if I'm thinking the pops as one of the evidence, so I have my manually defined score as another integration. So which means I'm define my open score. So I call my score as the author score at here, just for example. And that one is defined manually. So I have a manual label at here. And since that one is defined by humans, so there's no software supporting that. So I need a more free text description on the method to say how I define my score, why you show the strong or weak moderate at here. And it goes to a method part. For the column part, nothing different. Repeats the header name at here with a description at here. And for the evidence, which I mean like some used to, if I combine the evidence with the pops together, the pops go to the integrated analyze, and all the other evidence, single evidence, they go to the evidence stream. So it repeats it's the same as what I showed just now again. So that is what I mean for the integrated in another integration score. Yeah. Yeah, so that is the last entity. So really quick on the field format to say we can choose any field format we present our schema. It really depends on like the like any preference. For example, we want more user friendly for submitters, or we want more like machine friendly. But no matter which method we are, no matter which format we are showing at here, I want to say all of them, our schema can be represented in any way we want. And I'm showing the example in the YAML files. If anyone have a question on that, to show, actually the YAML file show the nested structures by the indentations. So you can say the orange goes to evidence category, or the green one goes to the streams, the purple one goes to the source and software, and the last one is a column. So once we have the schema, actually it doesn't matter which format we want. So they always can be organized into the way we like. That is for my presentation and some of the discussion. We have time, yeah, luckily. And yeah, so if anyone have any questions, you can just unmute yourself and go straight forward.
So there are a couple of comments in the chat. So Simon had a comment about the biosample used for QTL should be standardized with ontology.
Yes.
Which I think we were thinking of.
Yeah, I mean, there's multiple places where we could standardize with ontologies. You know, another place would be the manual versus computational. There's lots of different places that we could implement ontologies to help, for sure. And I think we'd need to do a review once we've kind of pinned down a little bit more what exactly we want to be in there, about what the most appropriate choices are. Yeah, but absolutely.
Are you using an ontology for biosamples in open targets?
Yes, we are using the Uberon and cell type ontology, I think.
Yeah.
So we have a full biosample index already ready. So, yeah. But, I have another question about this last piece of evidence that is integrated. I'm not sure if that should be actually computed by the one the person that submits the actual effector gene list. I think it could be computed afterwards. If we can consider that we are storing all the effector gene lists from different sources, we can actually integrate multiple of the same instance, I would say, right? Of the same instance of the loci, and then try to estimate if you have a better overall integration score at the end.
Yeah, I think one doesn't preclude the other. I think what we're trying to capture here is that what we see realistically, we also see these things in the literature, right? These are things that people do and they publish and they describe what they've done. So if we capture their integrations, that's fine, that can be used. But if we also have all of the other information, people can do their own integrations at will. Right, we're kind of trying to cast the net wide and not just think about like an open targets use case where you'll be trying to do everything independently. There's lots of other use cases that are more bespoke and derived from the literature or other places. And I think the other thing to note is that, well, that's probably enough for now.
Yeah. But I think that, yeah, we definitely want the standard to have all that information in so that you can apply your own integration. So essentially you could ignore that,
Yeah,
you know, we've
absolutely.
got that as a separate entity. So you can ignore that if you're not interested.
But I think the important point is that it's very clearly labeled that the author has done some integration work there, so
Yeah.
that it's easily ignored if that's what you want to do.
Okay,
Does
thank
that
you.
sound like it would fulfill
Yeah.
your use case? Yeah.
Yeah. I think that's fine.
What else? Any other comments? I mean, Marcus has some comments on making things compliant and interoperable with existing standards, and yeah, we definitely need to look at that. I think the one we were looking at was just like croissant, which is fairly high level, which I think we could make interoperable very easily. Yeah, do you want to comment on that?
Yeah, I would recommend that once you start with this realization, you definitely look at potential linkages to other standards. So
Yeah.
even if it's just one entity that you overlap with, at least that will be a linkage, because at least in our case in the EGA, we are always presented with cases that is not just a submission to the EGA, it's a submission to the EDI that is multi-omics. And it's very difficult later on, if you have not done these linkages across different standards, to link submissions across different archives as well, because they use different standards themselves. So I think it's pretty important. And you can integrate them, which is what I meant, directly into the serialization. So for example, and just briefly example, in my case that I presented in the Federated EGA, what I'm doing is literally referencing the schema of a different standard, so that by definition, if you are compliant with my schema, you're compliant with theirs. So if that makes sense, you can do those kind of fancy tricks, or you can do something more on lower base, but obviously that requires maintenance.
Yeah. Yeah, I think the GWAS catalog is one example, I think. But yeah. I'm mindful of time. Is there any other comments from the room, from the Zoom room?
I have one, but very, very brief, if that's okay.
Yep.
I was going to say that I believe you that this is very valuable, but once you start with the serialization, I think that you will find some trade-offs, and you will probably want to trade off some of the complexity that you're building here by embedding some of these entities. If they are not going to be reused, I would probably argue that they could be properties instead of entities themselves. So you will see how that works once you start with the cardinality of many to many, one to many, one to one, and you will see what actually is worth to be an entity on their own. Just a comment. That's one of my comments before as well, that I would probably focus on the abstract model first. While you obviously you touch on the serialization back and back, but I would not just leave it on the side, because I think it's very relevant down the line.
Yeah. Okay. Thank you.
Great.
That's super helpful. Thank you for the discussion, everybody. And if anyone has any thoughts afterwards, feel free to follow up with us on this or on the benchmarking activity. I'm sure Julie will send a doodle around regarding the next meeting, which I didn't really mention, but we're hoping to, and we'll remind everybody of the timelines by email, I think, Julie, yeah?
Yeah, we'll send that out, and we'll also send the recording and the notes for folks who couldn't make it.
Okay. Great.
All right.
Thank you, everybody.
Thank
Thanks.
Thank
Thank
you.
you. Take care.
you. Bye-bye.